Hello, welcome to Lesson 8, Area of Regular Polygons. For this lesson, when we're talking about regular polygons, we're really talking about things that have more than 4 sides, like pentagons, hexagons, octagons, maybe even a dodecagon. Our essential question is, what shape can every regular polygon be decomposed into? How can we cut it or divide it up into a shape that we could use to find the area of the polygon? First, what are regular polygons? Do you know what a regular polygon means? Regular polygons have all sides and angles congruent. Congruent means same size. So if you look at these examples, this first row is regular polygons. Here's an equilateral triangle. All 3 sides and all 3 angles are the same. If you look at this quadrilateral, it's a square. It has 4 right angles and 4 equal sides. If you look at this pentagon, you can see that all the sides are the same length and all the angles are the same. Whereas this is also a pentagon, but you can see this is a 90-degree angle and this is way more than 90 degrees. So this is not a regular. All of these on the bottom row are examples of irregular polygons. So for example, this red one is a hexagon because it's got 1, 2, 3, 4, 5, 6 sides, so it is a hexagon, but I think it's pretty obvious that all the sides are not the same length and all the angles are not the same size. So hopefully that clears up if you weren't sure what a regular polygon was. So if we look at some regular polygons, we've got a regular pentagon, regular hexagon, regular octagon, regular nonagon. So if we take our regular pentagon, we can break that into 5 identical triangles. 1, 2, 3, 4, 5. The hexagon has 6 sides, and we can break that into 6 identical triangles. The octagon, we can break that into 8 identical triangles. And the nonagon, yep, you guessed it, 9 identical triangles. So if I can break every regular polygon into triangles, how could I use that to find the area of a shape? Let's take a look at a problem. Patrick drew a regular pentagon with side lengths of 16 centimeters. So here you can see each side of the pentagon is 16 centimeters. He divided the pentagon into 5 identical triangles and measured the height of one of the triangles to be 11. And since all the triangles are identical, they would all have a height of 11. So they all have a base of 16 and they all have a height of 11. So to find the area of a triangle, it's 1/2 the base times the height. So in this case, 1/2 times 16 times 11. Half of 16 is 8 times 11, 88 centimeters squared. But I have 5 triangles, not just one. So I have to multiply 5 times 88 to get 440 centimeters squared. So the area of this pentagon is 440 square centimeters. Let's look at one more problem. Johanna has a hexagonal placemat. She measured the sides and found that they were all 9.3. So each side here is 9.3. She then divided the hexagon into 6 identical triangles. She measured the height of one triangle from the center to here was 8 inches. So the base is 9.3 and the height is 8. So 1/2 the base times the height to find the area of a triangle. So that's 1/2 times 9.3 times 8. I'm going to make it a little easier on myself and do 1/2 times 8, which is 4, and 4 times 9.3 gives me 37.2 inches squared. So I have 37.2 inches squared, but I'm not done. That's just this triangle. I have 1, 2, 3, 4, 5, 6 of those. So now I have to multiply 6 times 37.2 and I get 223.2 square inches. So the 223.2 square inches is the area of this entire hexagon. Now it's time for you to try 2 problems on your own to see if you can do it. And you can enter your answers on the Google form in the slideshow.